Okay, so now listen what we are doing, guys. We are starting with chapter 4, set G. Today, like we will be doing it from 61 to 69, all this question, if possible 60 also architecture. 61 to 69, this is related to chapter 4, set G. This set is very important from exam point of view, and it has lot of amendment changes every attempt it comes. Okay, so I will be teaching it you from my textbook, and even I will be telling you that in our ICAI book module, what is the page number? Correct? Correct? Yes. Very good. Now listen here. Now we are doing chapter 4, set G, grid computing. In ICAI module, the page number is 4.60. Answer is starting from 6.1. Benefits of grid computing. It's a star mark question, so please mark it. In my textbook, page number 4.33. What is grid? I will explain you. Now listen here. Listen very properly. What is grid? Grid computing. Now what is the concept all about? Now listen here. Grid. Now what do you mean by term grid? Grid means net. All the dots are connected with each other. Like for example, grid. Are you getting my point? All the dots are connected with each other. That usually we call as grid. Now listen, we are doing grid computing. Now what is grid computing here? Listen it very properly. Whenever I tell grid computing, computing means what? It will have some computing power, like calculations, transferring data, sharing data. Understood? Now, what is grid here? For example, first take a small example. These all are computers. These all are computers. Now when I say that these all computers are connected with each other, these all computers are connected with each other, it is called as network. When two computers connected with each other, it is called as network. But in grid, what is the advantage? A small basic thing I am telling you. Now suppose for example, if this computer having 10 GB of storage space, if this computer having 20 GB of storage space, if this computer having 10 GB again, this computer 5 GB. 1 minute, some problem in this pen. 1 minute. Okay. 10 GB, 20 GB, 10 GB, 5 GB, and in this computer we are having a storage of say 10 GB again. 10 GB again. So if you see, I am just typing the computer name here. 1, 2, 3, 4, 5. So there are total 5 computers. Now if you see, what is the storage space of computer number 1? Loud. 10 GB. Very good. What is the storage space of computer number 2? 3, 4, 5, 10 GB. Okay. So that is called individual storage space. But what is the total storage space? Total 20, 30, 40, 50. Are they correct? Yes or no? Okay, sorry, I took this 5 GB. Okay, sorry. 20, 30, 40, 50, 55 GB. So the total storage space is 55 GB. But if you count just computer number 1, then it is just 10 GB. But if you count all computers, then it is almost around 55 GB. So even computer number 1, we can tell like that what this is the power of grid. Now suppose there is a file of 40 GB. Now I want to store in computer 1, but do 1 have that much storage space? No. So what is the power of grid? The power of grid is that I can use 10 GB of computer number 1, and for more storage I can take storage of these all computers. Are you getting my point? I can take storage of different computers, but it should be in the grid, connected with each other. Are you getting my point? So this is the main function of grid. So the main function of grid is what I am telling you. Listen. Like for example, this 5 GB is not utilized at all. So we can utilize it, this 5 GB, we can utilize it for different computers which are on grid. So we can utilize the underutilized things. Are you getting my point? We can utilize what? Underutilized resources. So here I can take, here computer number 1 actually has storage of 10 GB. But virtually computer 1 has a storage of almost 55 GB. So this is the power of grid, where you can share your storage, you can share your many things with each other, but you need to be in the grid. Are you getting my point? Very important, huh? Very important. So listen. Now, the first benefit of grid is, first of all, this answer is star mark. The first benefit of grid is making use of underutilized resources. In most organizations, there are large amount of underutilized computing resources. Yes, large amount means what? The resources, the storage which is not utilized. Are you getting my point? Including even server machine. Server means what? A main computer which has lot of storage. Grid computing provides a framework for exploiting these underutilized resources, and thus has the possibility of substantially increasing the efficiency of resource usage. So we can use storage of some other computers which are underutilized. Are you getting my point? And we can utilize it to a maximum extent. Grid computing can be used to aggregate means sum up, total, this unused storage into much larger virtual data store. So if you see here, individual computer number 1, what is the storage capacity of computer number 1? But what is the virtual storage of entire computer number 1 and all the computers in a grid? 55 GB. Are you getting my point? Actually, I am having only 2 hands, but even your hands are empty, so I can keep some storage in your hand also. So suppose right now there are 50 students in class, so I can have 100 hands which are underutilized. So actually I am having 2 hands, but virtually I am having 102 hands. Your 100 plus my 2. Getting it? Yes. Very important concept of grid computing. Now, so if we use storage of some other computer which is underutilized, it will help us to improve the performance, and we are not dependent on any single machine. Means we are dependent on single machine because of grid. So because of grid, the other machines will help that single machine. Understood? Yes or no? Yes. So making use of underutilized resource. That is the main point. Read this point here itself fast. I am giving time of 1 minute. Do it fast. Making use of underutilized resources. Now listen here. Second point, very important. Resource balancing. Just tick mark the point. We are not doing all the points. Each point is of 2 marks. Resource balancing. Now listen here. Again I am drawing a grid. Now listen. Whenever I tell grid, that means all computers connected with each other. Are you getting my point? Now listen. Now listen. Earlier I gave an example of storage. Now I am giving example of RAM. What is RAM? Random access memory. What is it? I will tell you later, but just giving a brief introduction. RAM helps any computer to perform faster. To start any program, anything, we require RAM. Are you getting my point? Yes. To start any program, what we require, guys? RAM. So now listen here. Now I am giving this computer name 1, 2, 3, 4, 5. Now listen. These are serial number. Wait. Task. RAM required and priority. RAM require and priority. Now listen my answer very properly. Serial number 1. Now in computer number 1, I want to play. First let me give you the RAM size of each computer. Computer number 1 having 2 GB of RAM. 2 also having 2 GB. 3 having 2 GB. 4 also having 2 GB. And 5 having 10 GB. So if you tell me actually computer number 1, how much GB RAM having? 2 GB. But virtually? Loud? 18 GB virtually. Are you getting my point? So now I want to play a cricket game. The task is cricket. Cricket. Now cricket require 4 GB of RAM. Now tell me, cricket game is low priority or high priority for company? Loud? Low priority, because it is for entertainment. So whenever we run any task in the grid, we can set the priority. So I am setting the priority as low priority. Now along with, so here cricket require 4 GB. So here cricket occupied, here's cricket, here cricket. 4 GB occupied. Now I decided to turn on music. So second task is music. Music require total 12 GB. Music is low priority or high priority for company? Loud. Low priority. But storage RAM is available. So here we can start music. Yellow highlighter. 10 plus 2. 12 music. Now this is occupied, this is occupied, this is occupied. Now how much GB left? 2 GB. Only 2 GB left if we want to start anything on grid. Now listen here. Now I decided, let me do some office work also. So I decided to turn on Tally. Tally is accounting software, means I need to do lot of accounting work for my company. Tally is low priority or high priority for the company? High priority. So Tally requires, total 12 GB or say 14 GB. But Tally is high priority. Now what will happen? Is 14 GB available in the grid? How much GB available? Only 2 GB available. How much GB available in the grid? See here, only 2 GB available. So what this grid computing, one main benefit. When we set the high priority, the low priority work will get suspended or cancelled and make room for high priority work. Are understood? So what will happen here? To get 14 GB, this part will get cancelled. Music will get turned off. See, this 12 GB will get turned off. So this will become empty and even this will become empty. This both the things becomes empty. Now again we require 2 GB. 2 GB here it is available. Are you getting my point? So here Tally. And here 4 GB cricket. Are you getting my point? Are you getting my point? So what we have studied in this example, whenever we run high priority work, repeat, the low priority work will get suspended or even perform later to make room for high priority work. Say I am giving a small non-academic example, very simple, you will understand it very easily. This is junction. In Mumbai we tell Char Rasta, Chauraya. This is junction. What do you call here? Junction. Are you correct? This is junction. Now listen here. Now here there is one ambulance. Right now our signal is red. Ambulance signal is red. Here there is a traffic police. But right now the vehicles are going this direction. Now traffic police will see the ambulance. You tell me, is ambulance high priority as compared to local traffic? Yes. So what this traffic police will do? He will temporarily suspend this signal or suspend this traffic to pass by and let high priority work first go. Now after going, even they can restart it. Are you getting my point? So this is the power of grid. Making room for high priority work. The low priority work can even suspend it or perform later. Very good. Now listen. Resource balancing. For applications that are grid enabled, the grid can offer a resource balancing effect by scheduling grid jobs on the machine with low utilization. Underline scheduling grid jobs. These features of grid computing handles occasional peak loads of activity in a part of larger organization. An unexpected peak can be routed to relatively idle machines in the grid, the machines which are available. If the grid is fully utilized, the lowest priority work being performed on the grid can be temporarily suspended or even cancelled and can perform again later to make room for higher priority work. Understood? Yes or no? Yes. Yes or no? Yes. So this was our resource balancing. Second point of grid. Grid computing, very important, guys. Now, parallel CPU capacity. Parallel CPU capacity. Now listen, very important. Tick mark this point. Before this, just read resource balancing one time, fast. Now listen here properly. Parallel CPU capacity. Again I need to draw a grid. Now listen here. Just giving some numbering. 1, 2, 3, 4, 5. Now listen. We had done example of storage, we had done example of RAM, now we are doing example of CPU. We can also share CPU with each other. Now there are 5 computers. That means there are total 5 CPU. Are you getting my point? Now listen, a very small example I am telling, very small. Now I want to run a task in computer number 1. But the task requires, example, 5 minutes. To complete that task, it requires how much time? 5 minutes. Loud. 5 minutes. 5 minutes. What I can do, if computer number 2, 3, 4, 5 are freely available, I can use that CPU. Now the task which computer number 1 requires 5 minutes, it will get divided with all the computers in the grid. Now the task can be done in how much minute? Loud. 1 minute. Are you getting my point? Yes. So we can use parallelly multiple CPU. This will increase the power of computing or searching or any task. It will be done super fast. A small example, non-academic example, basic example. Say for example, there are total 1, 2, 3, 4, 5 students. Now this one student I am giving total 5 books to carry. But he is telling, sir, I can carry only 1 book at a time. Are you getting my point? So giving 1 book to this student, he will go here and he will come back. It will take 1 minute for 1 book. Are you getting my point? So for 5 books, how many minutes? 5 minutes. But now I realize that these 4 students are totally free. So what I will tell that student? Please carry one book each and go to that part and deliver and come back. Are you getting my point? Now my entire work will be done in 1 minute. Because I have used multiple CPU, multiple people, multiple parallel CPU capacity. Very important answer. Very important. Sleep, game over. Now listen. Tell very seriously. If not listening, call me then. Very seriously. Very. Go. Proper. Now. So this is the power of grid. Massive parallel CPU capacity. The potential for usage of massive parallel CPU capacity is one of the most common vision, underline, and attractive feature of grid. Massive parallel CPU capacity. A CPU intensive grid application can be thought as many smaller sub jobs. Like as I told you, I am having one task of 5 minutes. I divide that task into for 5 people 1 minute. Are correct? So the big job is divided into sub jobs. Are correct? So many smaller sub jobs are executing on different machines. See, job is big, but I divided into different sub jobs. Are you getting my point? To extent that these sub jobs do not need to communicate with each other, the application becomes more scalable. I will explain this line, don't worry. A perfectly scalable application will finish 1/10 of time if it is uses 10 times the number of processors. Are correct? 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 Now I am explaining this line, and this line will come ahead also. At that time I will skip this line. I am explaining it properly with non-academic example. Now listen here. Now for example, they don't have lectures, only full day. Now listen here. Now very important, listen up. Grid computing. One non-academic example I am telling. Say for example, this is me, my brother, my mother, my sister, and my father. We 4 people. Now my mother used to prepare food. Now today we are having guests at our home. So the menu for the guest is, listen, dal, rice, chapati, one vegetable, and buttermilk. Moru, sambaram. Now listen here. Now this is the 5 things we are preparing for guest. Now tell me one thing, is this 5 things related with each other or it is unrelated? Unrelated. So now at our home, if my mother will prepare all these 5 things, it will take around 5 hours. So now what we do is, we divide the task, and we are having also extra gas at our home, 5 gas, example. So now we divide the task. I myself will prepare buttermilk, I know that. My brother will prepare vegetable, buttermilk, vegetable, mother will prepare chapati, sister will prepare rice, father will prepare dal. Not understood? And these all tasks are not related with each other. So we can finish our entire task in 1 hour rather than 5 hours because I am using parallel CPU, parallel people together. Understood? Yes. So this was written in English. These sub-jobs do not need to communicate with each other. They are not communicating with each other. The application becomes more scalable. Are you getting my point? Yes. Yes or no? Yes. Yes or no? Yes. Read this point, very important. Parallel CPU capacity. Read this 3 points, very important. 1 minute. I am coming in 1 minute. Read these 3 points. Now listen. Done? Actually, I went to drink water. Now listen here. Now, parallel CPU capacity done. Correct? Yes. Yes or no? Yes. Now tick mark this point. Wait 1 minute. Access to additional resources. Now I think so you understood the meaning of grid. Grid means what? We can share everything with every other computer, whatever we are having it. Are you getting my point? Yes. See, first we shared our storage. Then second we shared our RAM. Third, CPU. Now fourth, internet. We are sharing our internet also. Like see, it is written. I will not draw again. The grid will understand. In addition to CPU and storage, it is written. In addition to CPU and storage, a grid can provide access to the other resources as well. For example, if a user need to increase their total bandwidth to the internet to implement a data mining search engine, the work can be split among the grid machine that have independent connection to the internet. In this way, your total searching capability is multiplied since each machine has a separate connection to the internet. Now you understood or should I explain it? See here. There are total example. Now we will take example of five computers. Okay. Now each computer has a separate internet connection. Separate internet connection. Now suppose each internet connection is 1 Mbps. So individual how much Mbps? Total 5. So if I am searching anything here, I can split my work, give half work to him and him. So the searching capability will be more faster. Correct? Yes. That is called as, we can use extra additional resources also like internet. Now last point, one more we are doing it. You can write in exam any 3 points. We are doing 5 points. We have done 5 points. Reliability, very easy point. High-end conventional computing systems are expensive hardware to increase. High-end conventional computing system use expensive hardware to increase reliability. The machines also use duplicate processors in such a way that when they fail, one can replace without turning the other off. Underline. If one processor fails without turning the other off. Power supplies, cooling systems are also duplicated. The systems are operated on a special power source that can start generator if utility power is interrupted. All this built a reliable system but at a great cost due to duplication of expensive components. Now listen, what does it mean? Listen here properly. Simple again. Now I am drawing a grid of only 3 computers. Are I correct? You will understand now. Now listen. This computer has extra power supply. Extra means having 2 power supply. This computer having extra CPU. There can be 2-3 CPU in one computer. This computer having extra RAM. Now, for human being, example, a non-academic example. What is important if we want to survive? Our heart. If no heart, can we survive? No. Same way, power supply, CPU and RAM are the heart. Now suppose if this computer power supply failed, then actually this computer should turn it off. Are understood? But if this computer is in the grid, automatically it will take power supply of this computer. If this computer having extra power supply, it will give it to him, this computer also, and without turning off, this computer will be remaining on. Are you getting my point? But to keep additional resources, additional extra things like power supply, CPU, RAM, all these things require money, expensive. Ultimately it is costly. Yes or no? Yes. Yes or no? Yes. So this is the next point, reliability. Now we have done what we had done. I am showing you this PDF. We had done 61. What is grid? Now you understood. Sharing. The same paragraph is written there. Benefit of grid we had done. Now we are doing types of resources in grid and application areas of grid. Very simple answer, because now you understood grid. So the types of resource and application area will be very simple. And then we will do grid computing security. So these 5 answers is related to grid. So let us do now further part. Types of resources in grid. Types of resources in grid is hash mark. So make it hash. Now what do you mean by types of resources? Listen. A computer in a grid, listen, first of all listen, a computer in a grid can be referred as nodes. These are the different names. Like one person can be brother, can be father, can be son, can be friend, can be teacher, can be grandfather. Are you getting my point? Same way, one computer can be node, resource, members, donor, client, host. So these are the terms. These all are computer only, but different terms. Are you correct? Yes. Now, where we can use this grid? The first point is computation. Already we have done this thing, computation. As I told you, first point, listen to computation. The first point. The 3 primary ways to exploit the computation. First, to run an existing application on an available machine on the grid rather than locally. Rather than locally means what? If I am running anything on single computer, it's better to run that everything on grid, so it will be faster. Are you correct? Correct. Yes. Second point we have already done. To use an application designed to split its work in such a way that separate part can execute in parallel to different processors. Like I've already taught you, massive parallel CPU capacity. Dal, rice, chapati, vegetable, buttermilk. All this thing will be running in different computer, different gas by different people. Are understood? Yes. So we can split our work in such a way that different tasks can execute on different machines of the grid. Are you correct? Yes. And third point, To run an application that needs to be executed many times, then we can use grid. So if one application we need to run 5 times, it's better use grid, run it one time, it will be multiplied by 5. Understood? Yes or no? Yes. Now listen. Second point also we had done storage. Grid is very useful for storage. The second most common resource used in this grid is data storage. Underline. A grid providing an integrated view of data storage is sometimes called as data grid. Each machine on the grid usually provides some quantity of storage for grid use. Are you getting my point? Like everyone has some storage. So that storage is available on the entire grid. Are you getting my point? Even if it is temporary. Storage can be memory attached to a processor, or it can be a secondary storage using hard drive or any storage are of two types. One is RAM, memory attached to a processor, that is a RAM, and one is secondary storage, that is hard disk storage. Full stop here. Done. So we can use storage of each other's, either RAM we can use or either hard disk storage. Are you correct? We've already done this thing. Now, very simple. Communication. Communication within the grid are important for sending jobs and their required data to points within the grid. The bandwidth available for such communication can often be critical resource that can limit utilization of grid. Redundant communication paths are sometimes needed to better handle potential network failure and excessive data traffic. Okay. In some case, higher speed network must be provided to meet the demand of jobs transferring larger amount of data. We have already done this thing. For example, if computer number 1 has low internet speed, low, can I use other computer internet speed? Yes. Second, what these people are telling, see how the grid is drawn. Listen, the grid is drawn like this. See here, 1, 2, 3, 4, 5. See, the grid is drawn like this. Now tell me only two path. Tell me. One wants to go to 4. Tell me one path. 1. Don't tell directly. Okay, 1 is 1, 4 directly. 1 is 1, 5, 4. 1, 3, 4. Are understood? So there are multiple paths. Now suppose for example, if this path is having lot of traffic or this path is not working. So what is the power of grid? We can send data through this path. Are understood? We can send data through this path. So this is what written in English here. Here, redundant paths are available to handle network failure or data traffic. So there are multiple paths. Redundant means duplicate, alternate path. So whenever I tell grid, that means 5 computer with star and circle. Are you getting my point? Next, software and licenses. Very easy. The grid may have software installed that may be too expensive to install on every machine on the grid. Yes. Some software licensing arrangement permit the software to be installed on all the machines of the grid, but may limit the number of installation that can be simultaneously used at any given instant. Okay, I will explain you. License management software keeps track of how many concurrent copies are stored. Okay, this is no use. Now listen, I am telling you. What is the power of grid? Listen, there are two things. Listen. Now, again, this is a grid. Now listen. Now I am purchasing a tele software. Tele. Worth rupees. Example, 50,000 rupees. License software. I am installing it in this computer. Now if I want to use tele for all 5 computers, then I need to buy 5 license. Are you correct? But what is the power of grid? Install only in one computer. Install only in one computer. Can be used by other computers in the grid, but not simultaneously. Like Netflix, you know. If you give me your ID password, even I can view. But simultaneously cannot view. Are you getting my point? Same way here. This is the power of grid. One license can be used by 5 computers, but not together. The advantage is that one license is enough for 5 computers. The disadvantage is that cannot be used by all the users. Are you getting my point? Together, simultaneously. Yes or no?
Yes.
Now, 5th point we are not doing. Only 4 points enough. Now, application areas of grid computing. Where grid computing is used. Hash mark. Any 4 points you have to tick mark. Very simple. Second point. It helps insurance company to mine data. See, grid computing is used for searching, mining, where a big task is there. Then tick mark this point. To forecast a particular stock. Because in forecasting, many charts, many patterns, many indicators, performance report of the company. So there are 20-30 things which should be done at a time. So if it is done by one machine, it will be very slow to forecast. Are understood? That's why grid. To give special effect in a movie. In scientific research, an entire network of computer to analyze data, to reduce the workload, internal, external workload. Done. 5 points enough. Now, grid computing security. Now listen. Now listen. This is star mark. Underline this line. To develop security architecture, following constraints need to be kept in mind. To develop security architecture, following constraints need to be kept in mind. There are total 9 points. We need to do at least 5 points minimum. So listen, I am telling you very easy points first. Tick mark this point. Secured single sign on. Secured single sign on. Most of the distributed computing systems used identity based username and password. Underline. Identity based username and password. Authentication means verification. Authorization means take permission for accessing a computing system. To access resource from different domains having different security mechanism, the user need to identify him to different domains. This is very irritating and time consuming process. To resolve this, a mechanism should be established in which a user authenticate once and are capable to acquire resource and release them when required. Now what these people are telling, listen here. Listen. See in grid. Listen. Now there are total 5 computers in grid. 1, 2, 3, 4, 5. Now listen properly. Now every computer has its own username and password. Now if computer number 3 wants some data from computer number 2, so 3 need to log in into 2 with username and password. Are you getting my point? Now 3 wants to get some data from 1. Again 3 need to log in with username and password. Now 3 requires something from 4. Again log in with ID password. Again log in with ID password. So this is irritating. So what these people are telling, when you are enter in this grid, to enter inside grid just keep one ID and password. Now once you enter that ID password correct, now you are free to do anything without further entering ID password further any more time. Are you getting my point? Are you getting my point?
Yes.
So this single sign on required. What required? Single sign on. Just Secured single sign-on means only one time sign it, you can access everything. Like say for example, if in your mobile, to make a call, you had set a password. To open WhatsApp, you had a different password. To open Instagram, different password. To open Zomato, different password. To open Swiggy, different password. Will it irritate you? So what is the solution? Just single sign-on. Everything will get open. Are understood? Are loud? Yes. Very important. Second point. Resource management. Grid resources are from different domains that have their own local resource manager. A grid does not have full control of all these resources. Allocation of resource to co-user, prioritizing local jobs over system jobs, and managing these resources without ownership is a big issue. Now listen what this means. Now I am just drawing a grid of 3 computers. 1, 2 and 3. All are connected. Now listen. Now listen. This computer 1 having 2 GB of storage. 2 GB. Why I have written inside? Because it is locally. Are you correct? Yes. Computer 2 having 5 GB and computer 3 having 4 GB. So 2, 5, 4. Now suppose for example, if computer number 1 has disabled sharing of this storage among grid, disabled, then this storage is of no use though this computer is in grid. Are you getting my point? Because this storage is locally occupied. Are you getting my point? Are you getting my point? Are you getting my point? So this is the problem. Like for example, non-academic example. I am having here 1 liter of bottle, 1 liter. Now there are 50 people standing outside my house. Please give me water. Now there are 2 possibilities. Either that 1 liter I give it to 50 people and I remain thirsty. Or either I tell that 50 people, no, sharing is closed for today. I want to use that bottle for my local single purpose. Are you getting my point? Are you getting my point? Same way, what storage, what RAM, what power supply we need to give to grid, that we need to decide. Are you getting my point? So resource management. Data management, very simple. The user data intensive, high performance computing application in a grid computing requires the efficient management and transfer of huge data. Providing secure, efficient and transparent access to distributed and heterogeneous pool of data is a big issue. Now listen here, what these people are telling, underline, providing secure, efficient and transparent access to data. See, in grid any computer is connected with each other, correct? So if you see, computer number 1 can access the data of computer number 2. Are you getting my point? Now some data which is very important, which 1 is actually not allowed, but then to 1 is seeing the data. So even this is the security constraint which we need to take care of, data management, that which data is allowed to the user and which data is not allowed to the user. Are you getting my point? Right here, which data is allowed, which data is not allowed. That needs to be managed. Write it fast. Done? Yes or no?
Yes.
Now, management of protection of credential, very important, very basic thing. Different multiple system in grid require different credentials. See, as I told you, like see, example, listen. Do you have password of n number of things? Like you are having Gmail password, Instagram password, Facebook password, some other login ID password, some other password. So it is very difficult to manage all the passwords. So what we do? We make a list of passwords with ID and we make one file. Or else we keep a standard password. Are you getting my point? To manage that, it is a big risk in grid. That is what? The management of password is a big issue. Are you getting my point? Tick mark that fast. Now tick mark exportability. The code should be exportable. They cannot use a large amount of encryption at a time. There can be minimum communication. Now what does it mean? Listen here properly. What does it mean? Listen here properly. Now listen properly. What these people are telling, listen. Whenever we send any data to any person in the grid, it should be encrypted. Encrypted means what? Secured. Are you correct? An encryption, like in WhatsApp, have you seen that there is an encryption facility? So, if you are sending big data, then it will go open. If you are sending big data, then it will go open. Open means what? Without any security. But if you are sending small data, then only it is encrypted. So, exportability means what? If you are sending bulk data in the grid from one computer to another, then you will not get that much encryption security facility. Are understood? Understood?
Yes.
Done 5 points. So, this was, even this point you can do very easy. Just tick mark, security part. So, this was the grid computing answer. Grid computing. This much. Which is very important. I hope students, you understood it. If any doubt, you can text me a message in my doubt solving number. Bye.